Hello guys. Hello guys, can you hear me? Are you getting some noise from my side? Yes, so is it disturbing or it is manageable? Just a second. Yes, so I understand there are some disturbance, but I cannot do anything actually. There's some construction going on upstairs. That's why it is. So I think it will be for half an hour more, half an hour, 45 minutes, because after that they'll stop working. So you have to manage for half an hour, 45 minutes. Okay, I'm sorry for that. Fine, guys. So what have we done last class? Can you tell me? I think we started with redox, right? Yes. Okay. So what was the last thing we have discussed? Rules for oxidation number. Correct. So we haven't seen the example. Okay. Okay. Fine. Fine. I got it. Let's begin with the session. So last class we had discussed about redox reaction, oxidation reduction. We were talking about. Okay. So the rules we had discussed already. Okay, you need black screen. Fine. Just a second. Just a quick recap. what we discussed last class. We have discussed the rules to find out the oxidation number. Definition of oxidation number also we have discussed. And we have discussed that for alkali metals, in short, I'll write down here. You have already done it, so you don't have to copy down this. Right? We have discussed for alkali metal, the oxidation state is +1. For alkaline earth metal, oxidation state is +2. Okay. For fluorine, it is the most electronegative element. Oxidation state is -1 always. Hydrogen +1 mostly. We have some exceptions. Right? We have seen in case of metal hydrides, it can show -1. Right? Oxygen is important. Oxygen has shows -2 oxidation state mainly, but in different conditions, like for peroxide it is -1, superoxide it is -0.5, ozonides -1/3, and oxygen difluoride it is +2, right? So oxygen difluoride OF2 is the only elements in which only molecules in which oxygen has or shows positive oxidation number. Okay. I have also told you what is the difference between oxidation state and oxidation number. Oxidation number is the total charge. Oxidation state is the average value, right? But for doing the calculation, we consider both as same. But there is a basic difference between the definition of the two that you must take care of. Okay, just a second. Okay, so we have also discussed for a given molecule. For a given molecule, the total charge, sum of the oxidation number is equal to the total charge on the molecule, and 0 if it is neutral, correct? Okay, we'll do some example into this so that you can understand how to find out the oxidation number. And this is the first step, very important, because everything is based on this only. If you have done some mistake over here, the entire other thing is wrong. Okay, so must understand this carefully. So let us find out the oxidation number of various elements. Here we have, write down the question, find out the oxidation state of atoms. Find out the oxidation state of atoms. And oxidation state here, it means the underlined atom. I'll show you which atom you need to consider. The first one is, we have SO4 2 minus. You need to find out for sulfur. Second one is NO3 minus. You need to find out for nitrogen. Third one is NO2 minus. You need to find out for nitrogen again. Then carbon monoxide for carbon, PO4 3 minus phosphorus, ClO4 minus chlorine. Okay, try these 6 and then we'll start discussing it. Do all of them. Okay, 653257. How do we do this? We assume on sulfur it is X and oxygen is -2. Total charge on sulfur is X. Total charge on oxygen is 4 into -2. And this should be equals to the charge on this ion, that is -2. Hence X equals to +6 here. Oxidation state. Nitrogen X plus 3 into -2 equals to -1 plus 5. X plus -2 into 2 is equals to -1. X equals to +3. It is -2. So on -2, so on carbon it is +2. Neutral. Phosphorus is X. So X plus 4 into -2 equals to -3. So X equals to +5. Okay. Chlorine is X. X plus 4 into -2 is equals to -1. X equals to +7. This is the oxidation state we have. This is one way. X you can find out like this. The another way, and sometimes the another way is very important. I'll tell you how to do this. And this thing you can use after chemical bonding mainly once you know the structure of the ion. Okay, for the another method, you should know the structure. Like, for example, suppose sulfate ion, I'm telling you, the structure of sulfate ion here is this one. We have sulfur double bond O, double bond O minus, sorry, double bond O, we have O minus and O minus. This is the structure for sulfate ion. Okay. You can ask me, how do you know the structure? How do we know the structure? How do we draw the structure of an ion? Okay. So yes, the answer for this question is a little bit of understanding you will have for the structure once you do the chemical bonding chapter. Okay, the structure related thing you will understand over there, but not all the things. You have to, keep this thing in mind that the structure we can draw this way. Obviously, if you study a little more chemistry, then you will have the idea of how to draw the structure. Okay, so basically the answer for your question is, with some more knowledge, some more time with if you spend with chemistry, 2-3 more chapters, you will get the idea of the structure of the given ion. Mainly after chemical bonding, you can do this, right? Which we'll discuss after finishing mole concept 2. Okay, redox, then mole concept 2, chemical bonding. Okay, so as of now, I'm telling you this: the sulfate ion is this molecule. Now, you should understand one thing you must take care of. Whenever oxygen is bonded with one single bond, it has one negative charge on it. Okay? If it is at a double bond, there is no charge. Right? When oxygen is bonded with one single bond, it has one negative charge on it. Double bond, no charge. Okay, so sulfate ion SO4 2 minus, since we have two negative ion here, two negative charge, two negative, hence we understand from this particular information that the two oxygen out of four is bonded with a single bond, and hence the structure, the bonding is this. Did you understand 10% of whatever I said regarding the structure of sulfate ion? Respond, guys. Correct? So that's how we can draw. Yes. So you have to memorize this. Okay, this thing you have to memorize, that oxygen, when bonded with single bond, it has one negative charge on it. Double bond, it has no charge. Two bond, oxygen, whenever we have two bonds, see, water molecule, right? It is neutral, no, there is no charge on oxygen. So whenever oxygen has two bonds, either in the form of double bond or two single bond like this, then it has no charge. Okay, but when the oxygen has only one bond present like this, it has one negative charge on it. This is what you have to memorize. Regarding its structure, you will study, you will understand this, you will have a clear picture of it after chemical bonding. There we discuss about BSEPR theory. We'll talk about structures and shape over there. Okay, as of now, I'm giving you this information that sulfate ion is this. If you talk about H2SO4, H2SO4 is also the same thing. Only with this negative charge, you attach hydrogen here. Done. This is H2SO4. Right? So if you remove H plus, you have two negative charges. Okay, and that is why you see H2SO4 is highly acidic. Because if you remove this H plus, I'm deviating from the topic, but I want you to connect with all the things that we have done so far. Why we said H2SO4 is an acid? You remove this H plus, you will get a negative charge here. This negative charge, you see, it is resonance stabilized. Are you getting it? Yes. Pi sigma lone pair, resonance stabilized. Guys, you forgot GOC. Yes. How was the KPI session? Because I think in that one you have a lot of reference of GOC he must have taken, right? How was the KPI session? Yeah, that's why I said the GOC we have done almost 80%, not all, but JEE advanced few things still there's left. We'll do that later. Yeah, I had a conversation with him. Actually. I told him to take SN1 type reaction. Okay. So to understand SN1, you should understand the carbocation stability and other things. Okay. So that's why that particular chapter, GOC, is very, very, very important. If you are not comfortable with GOC, you will have difficulty in entire organic chemistry. Tautomerism we'll do later. We'll do it later. Okay, I'll take tautomerism. Okay, don't worry. Anyways, coming back to this point. Okay, so what I was talking about. Why H2SO4 is acidic? Because the conjugate base of H2SO4 is resonance stabilized, and hence it is highly acidic. Even this H plus also you remove, this negative charge also resonance stabilized, and hence it is acidic. So this is all you can understand with this structure. Now the thing is how to find out the oxidation state with the given structure. Like I told you last class also we have discussed that two bond means for each bond we have one negative charge to more electronegative atom and one positive charge to less electronegative atom. Like suppose you have to draw the oxidation state of A and B. So if B is more electronegative and one bond is present, so we'll say -1 charge on B +1 charge on A. If you have A double bond B, B is more electronegative, then -2 on B and +2 on A because of this bond. Because we assume that the bond is ionic here. So plus minus charge you have to place. So here what happens, SO4 2 minus here, oxygen has 2 bond here, so -2 on oxygen because of these 2 bond, and +2 on sulfur because of the same 2 bond. Because of this 2 bond only, sulfur will have +2, oxygen will have -2. We'll have one bond here, so +1 because of this bond, +1 because of this one. So what is the total charge on sulfur? You see the total charge is +6, and that is what the oxidation state of sulfur. Did you understand it? Okay. Yes. Similarly, you see carbon oxygen, C double bond O, oxygen is -2, carbon is +2. PO4 3 minus. Have you heard the compound H3PO4? See, yes, or nucleophiles, electrophiles. Okay, there are many things. I cannot take all those things here, right? That would be very difficult for you to understand. So I have just taken the point, the thing which are very important for your KVA exam. These things, nucleophiles and other things, we will have in the coming session of organic chemistry. Correct? Yeah. See, if I tell you this is nucleophiles are either negative or neutral particles which attacks on the electrophilic center. There are many things into that. Good nucleophile, weak nucleophile, stable nucleophile, how a given ion is a good nucleophile. So all those things I did not want to go into that at that point of time. But yes, when we do it for JE Advanced, we'll discuss all those things. Okay, but whatever I have done, enough for KVA. Okay. Correct. Fine. So PO4 3 minus is. Have you studied about S3PO4? What is this S3PO4? It is orthophosphoric acid or phosphoric acid. Both are same thing. Okay. Could you draw the structure of S3PO4? S3PO4 structure is P double bond O, OH, OH, and OH. If you have to draw this PO4 3 minus, you see, you'll get PO4 3 minus once you remove this H plus, H plus, and H plus. Yes or no? Correct? So you remove this H plus, you'll get here PO4 3 minus, O minus, O minus, O minus. This is the structure of PO4 3 minus. Correct? Now because of this 2 bond, +2, +1, +1, +1. Is it +5 because of this structure? Are you getting it as +5? Yes. Yes. ClO4 minus. Could you tell me the structure of ClO4 minus? How do we draw the structure? ClO4 minus, the structure is chlorine with double bond O, and since you have one negative charge, yes, that's right, Pradyum. 3 double bond and 1 single bond. At least we can have this much of idea. Okay, this is enough. If you understand this thing, it is enough for this chapter. Okay, but like I said, chemical bonding will discuss how to determine the structure of any ion or molecule. Okay, now you see +2, +2, +2, +1, +7. This method, the structure method is important in the coming chapter. You will feel this, that the structure, even in this chapter also, I'll give you a few examples where the things are different. The structure and with the X formula that I have done. Okay, now we'll see some more example. Oh, I'm sorry. Okay. Try this. S2O3 2 minus S2O4 2 minus S2O5 2 minus S2O6 2 minus S2O7 2 minus S2O8 2 minus. All these you try. Okay. 2, 3, 4, 5, 6, 7. Okay. So how do we do it? X. We write 2x plus minus 2 into 3 is equals to minus 2. So x equals to plus 2. 2x plus 4 into minus 2 is equals to minus 2. So 2x equals to plus, 2x plus 6, x equals to plus 3. 2x plus 5 into minus 2 is equals to minus 2, x equals to plus 4, x equals to plus 4. 2x plus 6 into minus 2 is equals to minus 2, x equals to 5. 2x plus minus 2 into 7 equals to minus 2. So x equals to plus 6 and x equals to plus 7. Okay. This is the x method we have done it. 2, 3, 4, 5, 6, 7. Why not, Shitish? Okay, one doubt. Guys, listen. How come sulfur has plus 6 oxidation state? Anyone can explain this? Shitish, you can tell me why you feel and why you think that sulfur cannot have 6 oxidation state. What is your logic behind this? Others tell me, is it possible for sulfur to have plus 6 oxidation state? If yes, then how and why? See, very simple and basic answer for this one is any element which has D subshell, third period element, can have any possible oxidation state. You won't see second period element which does not have D subshell. They won't show more than 8, right? They won't show more than 8 electrons in their valence shell. But third period element can expand their octet. That's why they show high oxidation state. It depends upon the stability of those oxidation state. Copper and zinc won't show. +1, +2 only they show. Stability thing is not there. Okay. See, whether the elements can show or not, that's one thing. And if the elements prefer to be into that particular oxidation state, that's a different thing, right? So for sulfur, +6, +5, +7 is fine. For chromium, it's fine. Okay, manganese, it's fine. +7 oxidation state, it's fine. Because there are many things. It's not like only half filled and fully filled. There are many different, factors which stabilizes a given ion in a given structure. It's not like in elemental state. It's a given ion. No, it's a compound, a molecule, or ion. So how these atoms are arranged around it, that provides the stability, that affects the stability of one particular atom. All those factors we consider. Answer for your question, why it shows +6 oxidation instead of +7. The reason is it has d orbital, vacant d orbital, and it can expand its octet. That's why in the valence electron you see sulfur in this bonding state, sulfur has more than 8 electrons in the valence shell. Because it has d orbital, it can accommodate those electrons. Reason for D cell to show any oxidation, not any, higher oxidation state is a better way to say, right? Reason for D subshell to show higher oxidation state is that they can have maximum 10 electrons on it. So the third shell, if you consider, there are total 18 electrons possible, and hence exchange also possible depending upon their stability. And that is why more than 8 electrons is possible in the valence shell. See, that's a different thing. If you talk about the stability of this, then the stability of oxides we need to consider. We have to see the configuration of sulfur accordingly, we can say. But that is also won't work well or perfect in all the cases, because it's a molecule, that structure of the ions, oxygen, how the oxygen are placed around it, that affects the stability of these compounds. Yeah, I'll draw the structure. That's what I wanted to do. I'll draw the structure for all almost here. No, holmium won't show +9. The maximum possible oxidation state an element shows is +8, and that is for osmium, OS. Okay, +9 is not possible. Till now we know it's +8 for osmium. See, how an element shows positive oxidation state? By losing electron, right? By losing electron. And if you want to take that electron out, +8 and +9, you have to provide how many energies? I1, I2, I3, I4, I5. So that becomes difficult to, it's not like, theoretically, if you ask me, sir, there are 14 electrons in the shell, can we remove it? Yes, we can remove it. You provide that much of energy and remove 14 electrons, fine. But practically it is possible or not. That is what the case, and that is what we are discussing. Right. So practically to show +9 oxidation state, extremely high energy required. And it is just one factor. There are other things also. You keep on removing electron, that disturbs the stability of overall molecule, of all the molecules. And hence, to a certain extent, it can lose its electron. And that is what we know. +8 is the maximum oxidation state for an element. That is for osmium. Yes. No, for osmium is possible, right? Osmium OSO4, osmium tetraoxide, a very good oxidizing agent. We'll study this reagent in organic chemistry, OSO4, right? So it has +8 oxidation state into this one. Okay, we are not keeping. See, first of all, we are not keeping it +8 as the maximum. It is the molecule which keeps this particular thing. We are just trying to understand their properties. Are you getting which it is? It is other way, ulta hai. Okay? Do you understand Hindi a bit, all of you? Right? So this is ulta, little bit ulta, right? It's not like we are fixing the the oxidation state for an atom is plus it, chalo maan liya it's plus it is maximum. We are not doing anything into it. We are trying to study their properties, and we found that plus 8 is the maximum possible oxidation state of the element known, and that is for osmium in this. Not very easy to form. That's why most of the element does not form plus 8 oxidation. The reason I told you, you have to provide that much of energy to remove that electron, 8 electron, which is difficult to do. Hence it is. Correct? Can we move on? Osmium, let's start. We'll do this in D block elements. Okay. D block, F block, we'll study this D block elements in grade 12. We'll discuss in detail over there. The osmium oxidation state plus 8 and other things also. It's not like only one thing, other things also. Properties we'll discuss. Okay. So let's not go over there. Let's focus on this oxidation state, how to find out, correct? So let us try and understand the structure-based oxidation state here. First, we'll take S2O3. And this information I'm giving you that the structure of S2O3 or S2O6, if you see, the structure of S2O3 I'm drawing here, and this you have to memorize. Okay, S2O3. 2 minus we have, it means 2 oxygen can have one single bond, correct? So I'll draw the structure for this one. This structure is I'm giving you this information. S double bond S, then we have double bond O, single bond O minus, and single bond O minus. This is a structure of S2O3. Okay. Now you see, what is the X value we got here? What is the X value, Oro? Plus 2. Is it 3? It's plus 2, right? Yeah, it's 2. Plus 2. Correct. Chalo. So, Oro, this is plus 2. Correct, Oro? Fine. Here you see what happens here. This sulfur, you concentrate on the center one here, this one. And this is the oxidation state of sulfur, correct? This one, because of this 2 bond, what is the charge we should have here? Because of this double bond, we should have here plus 2. Single bond, plus 1. Single bond, plus 1. So what is the oxidation state for this sulfur? Is it right? Yeah. What about this one? It is 0 because we have same element. There is no electronegativity difference and no charge separation, hence 0. All of you, did you get this? Yeah. So if they ask you, very carefully listen to me, if they ask you the oxidation state of sulfur is plus 2. Then what is this plus 4 and plus 4? Plus 4 and plus 4 will write, if they ask you, the oxidation just a second. If I write down here oxidation number, it's plus 2. If I write down oxidation state of sulfur, you cannot write plus 2 here. Why you cannot write plus 2? Because oxidation state is what? It refers to the charge per atom. right? Charge per atom. So there are two atoms here. One atom has +4 charge and other one has 0 charge. So oxidation state, if they say, it means we should preferably write it. It's not like it is wrong. I'm trying to make you understand this. Just a second, Pratyuk. Oxidation state, preferably we should write it is +4 for one sulfur and 0 for the other one. This is also true if they ask the oxidation state of each sulfur atom in S2O3 2 minus. This is also +4 and 0 because one is +4, other one is 0. So +4 and +0 is the oxidation state of each sulfur atom in S2O3. On this, they have asked question in the exam. Okay. Then what is this +2? +2, you see, this is the average of the two, right? +4 +0 divided by 2, it is +2. So this value, the X method that you have, this X wala method, this method gives you the average value. Did you get it? Average value of all the sulfur atom. If they ask you what is the oxidation state or oxidation number of each sulfur atom, if they have written, then you have to consider each atom separately here. And in this case, the structure plays a very important role because if you find out with X, this always gives you average. This won't give you the oxidation state of each atom. And this thing is very important when we have more than one atom present, like here we have S2O3. If you have SO4 2 minus, then the oxidation number, oxidation state, everything is same because you have only one sulfur. The average is nothing but the value. So whatever method we use, X method or structure method, you'll get the same thing. But when we have more than one atom present, like in this case we have, in this case you have to be a bit careful. Yeah, that's what I said, Oro, in the beginning. That little bit of understanding you will have once you study a little more chemistry. Okay? For all these things, structure I'll tell you, right? And then you can keep those structure in mind. That is the one way. After that, when we do chemical bonding, you will have the idea of understanding the structure. It's not like you have to memorize all this. Not required. Okay? Just you spend some more time with this particular chapter, you will have the idea of it, how to draw the structure. Yes, it is. Okay, why it is 0? It is 0 because there are same atoms. If you have chlorine and chlorine bonded with, there is 0 electronegative difference, right? There's no charge separation. We cannot say it is -1 or +1. That is not possible because they have same atom, same electronegativity. Hence, the charge is 0 here. And that is what we have. Sulfur bonded with sulfur, we do not have any electronegativity difference. This +4 is because of these bonds. 1, 3, 4. Because of these 4 bonds. This double bond won't contribute anything to this sulfur or this sulfur. Hence, it is 0 on both. Yes, oxidation number here is +4 for the central sulfur atom, and the other one it is 0. Right? But always keep that in mind that whenever in the question they ask that oxidation state of each sulfur atom or whatever atom it is, okay, you must take care of the structure. That is very important. Like this sulfur oxides, all the structures are very important. So we are going to do one by one all these things, right? Like the second one, what we have the second one, tell me? The second one is S2O4, right? Let's see this, S2O4 2 minus. Okay, S2O4 2 minus, the structure is this. Very symmetrical structure. Once you see, you will memorize it, how to do this. Only one thing you have to keep in mind, that one negative charge oxygen will have when it is bonded with single bond. Okay, so how many oxygen should have single bond here in SO4 2 minus? How many oxygen should have single bond? 2. So we'll draw this information. You can draw the structure. You see, sulfur double bond O minus, O minus. This is the structure. So this you see, it is +3 here, right? 2 plus 1, 3 bond. This is sulfur-sulfur bond, won't contribute anything because zero electronegativity difference. So this is +3 and this is +3. So here the X value also gives you the same thing because we have symmetrical arrangement in the structure, right? So oxidation number, oxidation state, both are same here. Clear? S2O5 2 minus. That is what the structure of this H2O4 2 minus. Guys, the structure thing, like I said, we'll understand Lewis dot structure in the next chapter. You will have a better idea of it. I don't want to go into that because that will take a lot of time. Okay, so here for this chapter, what you do, just try to memorize this structure with the given information that oxygen when bonded with one single bond, one negative charge. Only this much you keep in mind and try to figure out the structure with the base of that. Again, I'm repeating, you will have all this idea when we do Lewis dot structure in chemical bonding chapter. Okay, that's not a big deal. Easy also, it's not tough. Okay, I can discuss now, but it will take time. There are 8 to 10 rules. Okay, those rules and then examples we have to see. Okay, that's why I don't want to go now into that. Okay, we'll discuss in chemical bonding. Okay, so I'm just giving you these structures. Try to or must write it down and try to keep that in mind that the structure is this. S2O5 2 minus. The structure is S double bond O. We mostly have sulfur-sulfur linkage in all these structures. Okay, few exceptions we have. We'll discuss those exceptions also. But mostly we have sulfur-sulfur bond present in all. This is S2O5 2 minus. You see the X value. What was what here? What was the X value? Could you tell me? It was +8, right? +4. I'm sorry. It was +4. Yeah. And if you find out this here, it is 2 plus 2, 4 plus 1, 5 here. 5 bonds. 2 plus 1, 3 bonds. Now look at this. 5 plus 3, 8. 8 divided by 2, that is 4. This is the average. Clear now? Are you getting it? Yes, tell me. Correct. So X method gives you the average value that we understood. What about S2O6 2 minus? You see this? S2O6 2 minus, the structure is two, 4, 5 here and 2, 4, 5 here plus 5. So it's symmetrical, same value we have, hence average is also +5. S2O7 2 minus, this one is important. Yeah, I think GOC is there in ChemOn. You must have that syllabus in the group. Check once. GOC atomic structure and mole concept is there, I guess. I forgot long back I have given the syllabus. It's that only. GOC, atomic structure, and uh, this thing, mole concept. Okay, S2O72 minus. You see this. In S2O72 minus, we have sulfur oxygen sulfur bond. No, this test you do not have. I'll update you, or let me just check once because I have given the syllabus long back. Let me just check this once, okay? I'm not very sure. But most probably it is GOC, atomic structure, and mole concept. Okay, so this one you see, it is 2, 4, 5, 6 plus 6. 2, 4, 5, 6 plus 6. S2O72 minus. S2O82 minus is the most important one. S2O82 minus is the most important one because it has peroxy linkage. Peroxy linkage is oxygen-oxygen bond like this. Double bond O, double bond O, O minus, double bond O, double bond O, O minus. This is the peroxy linkage. Must remember this. Peroxy linkage examples are very important for competitive exams like JEE or NEET. Okay. So this is the peroxy linkage, oxygen-oxygen bond. And I've told you in case of peroxy linkage, the contribution is plus 1, right? So here we have minus 1, plus 1, 2, 4, 5, 6, plus 6 we have here, and plus 6 we have here also. Plus 6 and plus 6. Okay? Try this one. S4O62 minus, sulfur you need to find out. S4O62 minus, the structure is this. S 4 sulfur atom, double bond O, double bond O, O minus, double bond O, double bond O, O minus. So on the terminal sulfur you see it is 2, 4, 5 plus 5. This is also plus 5, and this 2 there's no electronegativity, 0 and 0. So if they ask you the oxidation state of each sulfur atom, answer is plus 5, 0, 0 and plus 5. X method if you apply here, it is 4x plus 6 into minus 2 is equals to minus 2. So that would be x, you see it is 2.5 you are getting, yes or no? 2.5. So this divided by 4 is again 2.5. Done? No, they'll ask in a question. If they ask of each sulfur atom, you have to write down the individual values, right? If they write down, if they ask what is the oxidation state simply, then you can take the average one. Find out for sulfur H2SO5. This molecule we call it as Caros acid. Name is also important. CrO5, chromium. Yeah, I know, but yes, ignore this. Don't see. I'm using my mobile network. Actually, my Wi-Fi. Yes, okay. I, I don't know. Actually, my Wi-Fi is not working today, so I am using my phone network. That's why maybe the connection is not that great. I'll try to write with a bigger font size. Maybe that helps probably. Okay. H2SO5 is Caros acid. Okay, Caros acid, double bond O. Just a second, let me check. It's fine now. It's fine now. Okay, that will get better. Or okay, you have to manage today. Actually, it's out of my hand. I can't do much here. Okay. Anyways, so H2SO5. I'll try to write with a bigger font size. Maybe probably help. Okay. S double bond O. Um, then we have double bond O this side, OH, and here also we have peroxy linkage, OOH. Wherever you see this bond, OO bond, it is peroxy linkage. Okay, so if you find out for the sulfur, it is X, so 2 plus 4 plus 5 plus 6. Here the oxidation state for sulfur is plus 6. Right, so H2SO5 is Caros acid. Okay, it's important. Okay, the name also important, you must take care of. CrO5 has a very beautiful structure, and that structure we call it as butterfly structure. You see this structure here, CrO5, chromium in the center, and we have peroxy linkage. In fact, two peroxy linkage we have here, like this, and double bond O. This is the butterfly structure. These are experimentally determined. So you have to memorize this. So plus 2, 4, 3, 4, 5, 6. Plus 6 is the oxidation state for chromium. Right, so Carros acid has peroxy linkage. CrO5 has peroxy linkage. Okay, and one more structure, there is CrO8 3 minus. The structure is we have chromium, and chromium has -3 charge on it. This -3 on chromium. Now there are 8 bonds 1, 2, 3, 4, 5, 6, 7, 8. So plus 8 and -3 already we have here. So the oxidation state of chromium is +5 in this. Again has peroxy linkage. Done. One very important example, oxidation state of each nitrogen atom in NH4NO3. Find out oxidation state of each nitrogen atom in this. Hello? Can you hear me? Can you hear me, guys? You there? Okay. So NH4, network error. Okay, I'm sorry for that. Okay, NH4NO3, you need to find out the oxidation state of each nitrogen atom, correct? So see, here if you take X method, again you will have a wrong answer here. This is a compound and it exists as NH4 plus and NO3 minus. So this is X. So here you can use this. X plus 4 into plus 1 is equals to plus 1 and hence X value is minus 3. Here if you find out this, X plus minus 1 and X value is plus 5. This is the answer for this. So plus 5 and minus 3 is the answer. Yeah, I'll go back to him just a second. Plus 5 and minus 3 is the answer. If this molecule I'll write down as N2H4O3 and use this X method, then that would be 2x plus 4 into plus 1 plus 3 into minus 2 equals to 0. And when you solve this for x, what is the value you are getting? Is it plus 1 you are getting? Plus 1. So what is this plus 1? This plus 1 is the average value. It's not the oxidation state of each nitrogen atom. It is the average value that you can also cross check from this two. Average is what? Plus 5 plus minus 3 divided by 2, that is plus 1. Okay. Now, one very good example which has been asked in J exam. Okay. Find out the oxidation number of each fluorine, iron atom in Fe3O4. Oxidation number of each iron atom in Fe3O4. 3, 3 and 2. Okay. How did you do this, Shitesh?
Sir?
Yeah.
Sir, I can't message you, sir.
I can see your message. Who is this, by the way?
So it's Aurav.
All other can do. Shitesh is texting me.
So whenever I try to message you, it says chemistry class is not in this meeting.
Okay, what you do, you just leave and join again.
Okay.
Also, the
Yeah.
same thing is happening for me also.
So you can rejoin, guys. If you are not able to text, you can rejoin, all of you. Okay. Hexagonal pattern. Okay. One O in the middle. Yes, Taro, I can see. Okay, see, actually, yeah, coincidentally, you got it right, Shitish. Your answer is correct, but actually, this molecule, it is an additional compound, and it exists as FeO dot Fe2O3. Two oxides of iron we have, in which the oxidation state of each fluorine atom, if you iron atom, if you consider, it is +2 and +3. Hence, answer for this question is +3, and +2. Very important, have asked in JEE exam this question. Okay, it has two different oxides present. Yeah, just a second, I shall go. Yes, they got. One second, guys. I'm just forwarding. Yes. Just a second, Arab. Uh, we have to forward a video to one of your batchmates. Almost done. Yes. Okay. So this is the examples we have discussed for how to find out the oxidation state here. Correct. So there are few groups or ions we can say on which you should know what is the charge present. Like the sulfate ion. What is the charge on sulfate ion? It is -2. Cyanide -1. So these kind of ions we have that you should know. So write on the heading on the top, charge on ion. All these are basically information that you are going to apply in the question when you solve it. Okay, so this you should know. Sulfate ion, if you have sulfate ion, is SO4 2 minus. Okay, cyanide ion is Cn minus. If you have ammonium ion is NH4 plus. Oxalate ion. You know what is oxalic acid? What is oxalic acid? COH, COH, right? Hold twice. What is that, Shitish? Oh yes, that is what you said. Yeah. So oxalic acid is this COOH, COOH, and when you remove H plus from this, you'll get C2O4 2 minus. It is oxalic acid minus 2 charge on this. Okay, all these are important. Nitrate ion is NO3 minus. Nitrite ion is NO2 minus. Okay. Uh, chloride ion. Chloride ion is ClO2 minus. If it is bromide, then BrO2 minus here. Okay. If it is nitride, NiTride. If it is nitride, then N3 minus. It is not N3 minus, N3 minus negative charge. The next one is chlorate. Chlorate is ClO3 minus. Perchlorate is ClO4 minus. Carbonate is CO3 2 minus. Trisulfate, not very important. S2O3 2 minus. All these things are not important, but obviously first four, perchlorate is important, nitrite is also important. Okay, these 5, 6 things. Okay, so we have discussed the basics here, right, of redox reaction, which will apply in the question. So now we are going to see what is a redox reaction, the oxidation reduction reaction, and how do we balance the oxidation reduction reaction. Okay, so write down the heading: balancing of redox reaction. Balancing of redox reaction. The most important method, and we are going to this only to do this only in the class, because this is the most important one, and this one they are going to ask in the exam also. That is ion electron method. ion electron method. See, guys, ion electron method we use for all the mediums, acidic medium or neutral medium, basic or alkaline medium. Okay, but there are certain rules to balance a reaction in different mediums. Okay, so what are those rules? First, we are going to see one by one the rules, and then we'll take up some example and we'll do this. Okay, so write down rules here. All of you must write down the rules properly because this is what we are going to use in solving questions. Okay, so if you do not write, you won't be understanding that thing. Okay, so first point to write down, the first rule: divide the equation. Divide the equation. I'll go slow, okay, so that all of you can write this. Divide the equation into two halves. Divide the equation into two halves, that is oxidation half and reduction half. Divide the equation into two halves, oxidation half and reduction half. Done. Divide the equation into two halves, oxidation half and reduction half. Second point, balance all atoms. Balance all atoms balance all atoms other than oxygen and hydrogen atom. Again, I am repeating this. Second point, balance all atoms other than oxygen and hydrogen atom in each half. Okay, balance all atoms other than oxygen and hydrogen atom in each half. Third point, depending upon the medium, depending upon the medium, balance oxygen and hydrogen atom in each half. Repeating this, depending upon the medium, balance oxygen half, sorry, balance oxygen and hydrogen in each half. These 3 points, 3 rules are common, whether the medium is acidic or basic. Now the balancing of oxygen and hydrogen, that we have different way in acidic medium and basic medium. So how to balance oxygen and hydrogen when the medium is acidic and when it is neutral, sorry, basic. So first point in this you write down, means the third point you have written. Under this third point, you write down acidic and then point number A in this. Okay, write down. Oxygen atom is balanced by adding water molecule. Oxygen atom is balanced by adding water molecule on oxygen deficient site, adding water molecule on oxygen deficient site. Okay, you just write down the rules here. With example, we'll understand each and every point. Okay, don't worry. Okay, acidic first point. Oxygen atom is balanced by adding water molecule on the oxygen deficient site. Okay, second point, hydrogen atom. Write down hydrogen atom. B, point number B. Atoms are balanced by adding, hydrogen atoms are balanced by adding H plus to the other side. Okay, this 2 point to balance oxygen and hydrogen we use in acidic medium, and this is equally true when the medium is neutral. Okay, acidic or neutral medium will follow the same rules A and B that you have done. Okay, now on the third point we are doing this. Okay, so what we'll do when the medium is basic or alkaline. So in this one, you write down the point number A. Point number A. Excess oxygen atom is balanced by adding H2O molecule on the same side H2O molecule on the same side and OH minus ion on the other side. Excess oxygen atom is balanced by adding H2O molecule on the same side and OH minus ion on the other side. In this A only, next line you write on one line you add this here. For one H2O molecule, we add 2 OH minus ion. Yeah, I'll repeat answers just a second. Okay guys, all of you, I am just repeating myself the second step of acidic medium. Those who have written, fine, otherwise you can write it. Second step of acidic medium. Hydrogen atoms are balanced by adding H plus ion to the other side. Okay. Hydrogen atoms are balanced by adding H plus ion to the other side. This is for acidic medium. Okay, next we have basic medium or alkaline medium. The first point of basic medium is excess oxygen atom is balanced by excess oxygen atom is balanced by adding H2O molecule on the same side, H2O molecule on the same side, and 2 OH minus ion, and 2 OH minus ion on the other side. H2O molecule on the same side and 2 OH minus ion or OH minus ion on the other side. One point you have to keep in mind, for one H2O molecule, we add 2 OH minus. If you are adding 2 H2O, then 4 OH minus. 1:2 ratio we have there. Okay. Next point for basic medium. For every excess for every excess hydrogen atom, for every excess hydrogen atom, add 1 OH minus ion, add 1 OH minus ion on the same side, add 1 OH minus ion on the same side and 1 H2O on the other side. 1 H2O molecule on the other side. Okay, again I am repeating this point. For every excess hydrogen atom, add 1 OH minus on the same side and 1 H2O on the other side. Done, all of you? If you have written, please tell me. Any point, specific point you want to repeat? Done. Okay. Next, this all under point number 3. Then point number 4. Two more points we have. Point number 4. Balance the charge by adding hello. Yeah, guys, one thing. Since the network is poor, so if I get disconnected, I'll join soon. Okay. So some, if one of you once I join, okay. So don't get panic. Am I audible, guys? Am I audible? Okay, yeah, fine. The network is fluctuating, that's why it's happening. Okay, don't get panic. Okay, calm down. Yeah, I understand there is some network problem today. Anyways, it fluctuates, that's why it happens. So the fourth point you have written, balance the charge by adding suitable number of electrons on one side. Okay. Last point, write down, multiply both equation, both equation, multiply both equation by a suitable integer multiply both equation by a suitable integer. Priyam, you write down this point and then I'll repeat the last one also. The last point is multiply both equation by a suitable integer so that the free electrons gets cancelled. Yeah, fourth I'll just repeat, wait a minute, just a second. So that the free electrons, so that the free electrons get cancelled when we add the two equation. When we add the two equation. Fourth point I'm repeating again and then fifth point again I'll do. Fourth one is balance the charge by adding suitable number of electron on one side. Balance the charge on adding suitable number of electron on one side. This was the fourth point. The fifth and the last one is multiply both equation by a suitable reagent. Multiply both equation by a suitable reagent so that the number of electrons get cancelled when we add the two equation. When we add the two equation. Are you done? All of you done? Yes, third point for basic is, it's not the third point. Basic also we have the two points here. The basic medium I'll repeat. The balance the charge one is the fourth point, not the third one, is the fourth point. Okay, fourth point is balance the charge by adding suitable number of electrons on one side. Balance the charge by adding suitable number of electron on one side. Done? Tell me, all of you have written? Shall I proceed with the example? Correct. So this is the theory, okay, the rules and all. But you will understand this once you practice some question, okay? So with practice, you will memorize this also. You don't have to memorize it separately. Like, let us take one example and discuss the balancing of redox reaction by ion electron method. Okay, so the reaction is, the given reaction is, we have FeSO4 plus KMNO4 plus H2SO4 For some reactions, you'll feel like you'll balance the reaction by hit and trial only. Okay, that you can do, but we have to understand here what is ion electron method. So we'll try to use or apply the rules that we have written just now. Okay, FeSO4, KMnO4, H2SO4, it gives Fe2SO4 whole thrice plus we have MnSO4 and then we have K2SO4 and H2. 1 second, guys, I'm coming. Yeah, someone was there at the door. Anyways, so this is the equation given. We have to balance this equation by ion electron method. So what is the first step? Could you tell me the first step? The first step is we have to divide the equation into two halves. One is oxidation half, other one is reduction half. Okay. Could you tell me the oxidation state of iron here? See, I'll write down here just a second. First of all, you see H2SO4 is given, so the medium is acidic. Am I audible, guys? Okay. Medium is acidic. Now we divide this equation into two halves. So I'll just, in short, I'll write down the steps. Divide the equation into two halves, right? One is oxidation half, other one is reduction half. So just tell me the oxidation state of iron here and oxidation state of magnesium. Tell me, guys. Yes, oxidation state of iron is okay. So manganese is +7. Okay. So how to find out for iron? You see, we know this is iron sulfate. Iron sulfate is -2 charge. So iron is in +2 oxidation state. Okay. Manganese, if you find, it is +7 here. Okay. Here manganese is +2. Iron is +3. And that is what the change we have here. All other elements, if you see, both sides, the oxidation state is not changing. Right? So we have to write down first here the oxidation half and reduction half. I'm going very slowly here so that you can understand this. Okay. Oxidation half is the one where oxidation state increases. Means for which, for the atom or ion, if oxidation state increases, it means oxidation is taking place. For which atom the oxidation state is increasing? for which atom the oxidation state is increasing. Oxidation state here, it decreases for reduction, just opposite, ulta, right? So it means what? We say that iron is going under oxidation and manganese is going under reduction. So both oxidation and reduction is taking place simultaneously. Hence the reaction is redox reaction. Any doubt till here, you can ask me. Because this is the first step, and take my words here. If you make a mistake, like, is there any possibility of making a mistake? It is this step, to write down the two half. If you write down this two step properly, other things is just the rule that we have to follow. That's why you must understand this. Okay? Any doubt till here? You can ask. 30 seconds. Am I audible to all of you? Yes? Please tell me. Tell me, guys, can I proceed? I hope yes. Okay, you're not replying. Maybe. Okay. So, so how to find out the oxidation half and reduction half? By calculating the oxidation state. If you make mistake over here, everything is wrong after this. Okay? So that's why the oxidation state is very important. Okay. So once you know which atom is going under oxidation, you just have to write down here the equation is. So Fe2 plus is converting into Fe3 plus ion here. So I'll write down the equation here in the form of ions. We'll use here in the form of ions. Means what? This Fe2 plus is converting into Fe3 plus. And since we have 2 Fe here, so I'll write down 2 Fe3 plus this side. Right. This is the oxidation half. Fe2 plus to convert into Fe3 plus, oxidation half. Whenever oxidation state increases, oxidation half. Reduction half is what? K plus, won't change. And always keep that in mind that oxygen will write down into this. So K plus MnO4 minus. So it is MnO4 minus converts into MnSO4 gives you Mn plus 2. Tell me, any doubt in this? Hello? Gurman, any doubt? Oro, is there? Aditi, what happened? Any doubt here? Clear, Parvati? Okay, very good. Okay, so this is what the thing is. Always keep this in mind that this is the ionic form we are writing it down. MnO4 minus. It's a molecule. We convert this into ions. MnSO4. We convert this into ions. Okay. If you done this thing correct, then after this it is just the rules that we have to follow. Okay. So I guess all of you have understood this. Two half I have written. How do you know that this one is oxidation? Oxidation state is increasing. Hence oxidation it is. Reduction is what? Oxidation state decreases +7 to +2, hence reduction. So first of all, we'll find out the oxidation state and we can easily check which one is going under oxidation and reduction. So this is what the first step. Okay. Now, depending upon the medium, we have to balance oxygen. And before that, we have to balance all atoms other than oxygen and hydrogen. So is this equation, in this equation you see, Iron is balanced, yes or no? Is it balanced, iron? No, it is not balanced, correct? To balance iron, just charge unit, we don't bother about this charge, plus 2 and plus 3. Just focus on atoms first, okay? 2 Fe here, only 1, so to balance Fe, we'll multiply here. Second rule it is this, second point, okay? I want you to refer the rules in every step, okay? Balance all atoms other than oxygen and hydrogen. So here we do not have oxygen and hydrogen present, we have iron, so we'll balance Fe here. Manganese in this equation is balanced, yes or no? Already balanced. Okay, so we don't have to do anything. The second step is done over here. Third step is what? Depending upon the medium. What is the medium here? Medium is what? Acidic medium. So we'll apply the rules for acidic medium to balance oxygen and hydrogen. So what is the first rule of acidic medium? All of you want to see this? First rule of acidic medium, oxygen atom is balanced by adding water molecule to the oxygen deficient side. Okay. So in this, do we have oxygen? No. Let it be as it is. Here we have oxygen. There are 4 oxygen present here. So we have to add water molecule here in order to balance the reaction. Oxygen deficient side. Okay. Hence this side. But how many water molecules we should add to balance this oxygen atom here? How many water molecules, guys? Yes, the number of water molecules depends upon the number of oxygen atom present over here, which is 4, hence it is 4. Correct? So oxygen is balanced. Right? So oxygen is balanced. Right? Now, what to balance? Manganese is balanced, oxygen is balanced, but hydrogen is not balanced here, right? You add H2O in order to balance oxygen, but you have added hydrogen also here. Now, to balance hydrogen, what we need to do? Read out the second point of acidic medium. Hydrogen atoms are balanced by adding H plus to the other side. Okay. How many H plus we have to add this side? Please respond, guys, all of you. How many H plus we need to add this side? According to rule number 2, acidic medium. How many H plus? How many H plus? 8, because we have 8 hydrogen here. So 8 H plus this side we add. Don't bother about charge now, till here. Right? You don't have to bother about charge. For charge, we have the fourth step. For charge, we have the fourth step. Now, till here, all the atoms are balanced. Right? Iron is balanced, manganese, oxygen, hydrogen, everything is balanced. But charge is not balanced here. Right? What is the total charge this side, guys? First equation you see, what is the total charge this side? One more thing before going into the charge, one more thing. It is also possible that in both the equation you will have oxygen hydrogen present. So in that case, this rule H2O and H plus will apply in both. That's not a big deal, right? Since we do not have oxygen here, so we are not doing anything into this. If it is there, then we'll follow the same rule. Correct? Now tell me, what is the total charge this side we have? Total charge? +4. Kshitij, is there? Yes. Total charge is +4. Are you getting it, Kshitij? +4, right? 2 Fe2 plus and 2 into 2 +4 this side. What is the total charge here? +6. And how do we balance the charge? By adding electron. Electrons are negatively charged. So where we should add electron, right side or left side? In order to balance the charge. How left, Kshitij? Left side, if you add, then charge decreases, no, +4, and you are adding some negative charge into it. We have to decrease the charge this side, right? Hence, we have to add electron on the right side so that positive negative will cancel out and the charge reduced to 4, right? But how many electrons again? How many electrons? So that the charge becomes equal. Very good, 2 electrons. So this equation is balanced. Everything is balanced. Atom is balanced, charge is balanced, everything is balanced. Okay? This is what you have to do in the second equation also. Could you tell me how many electrons on which side we have to add in the reduction half? Calculate this. How many electrons on which side we have to add in order to balance the charge? Second one. 5 in the left. Is it 5? Very good, Aditya. I think it's correct. 5 in the on the left side. Why? Because you see 8 positive and 1 negative. Total net charge, if you count here, it is 7 positive charge. Total net charge, if you count here, it is neutral 0 plus 2 plus 2. So 7 to plus 2 you have to go. So the difference is 5. We need to add 5 electrons this side. Any doubt in this? Any doubt? All of you, I want you to respond. All of you, please, guys. No doubt? Clear. Now, what is the last step? This is still fourth. We have reached to the fourth step. What is the last step? Multiply both equation by suitable integer so that no electrons, so that the free electrons gets cancelled when we add the both. See, actually, the last step when you balance everything, then we have to get the equation in this form because we have divided this equation into 2 halves. Now to get the final equation, we have to add the 2 also. This 2 we have to add, but there is no free electron in this equation. So we'll add these 2 halves in such a way so that these free electrons gets cancelled. Okay, and for that we use some integer. So what integer we use here, you see, if this equation I'll multiply by 5 and this equation I'll multiply by 2 and add the 2, then this electron and this electron will get cancelled. Yes or no, guys? Is it right? If we add the 2 electrons equations like this by adding 2 and 5, the electrons gets cancelled, and that is what we have to do. Cancel means there is no electron present. 10 electrons, you are adding the 2, this and this will get cancelled. Both are on the opposite side, no? So it will get subtracted. Yes, this means what? If you place this electron on this side, then this 5 electron becomes minus 5 electron on this side. Now minus 5 into 2, minus 10 electron on this side, 5 into 2 plus 10 electron on this side, so plus minus will get cancelled. Continue. Clear? Okay. Now the last step, listen to this very carefully. The last step, what we do? The last step is, we just write down everything. You see, 5 into 2, 10 Fe2 plus. Okay. Then 2 into MnO4 minus, 2 MnO4 minus. 2 into this 8, 16 H plus. Now on the product side, 5 into 2, we have 10 Fe3 plus. 2 into Mn, 2 Mn plus 2. 2 into 4, 8 H2. And electrons will get cancelled. Okay. Based on this, I want you to look at this equation. This is the balanced ionic form of this equation we have. Okay, no problem, Arya. You can join from here. Anyways, I'll share the video. Okay, you can watch that. And second example will do, you can understand, not an issue. Okay, this is the balanced ionic form of this equation. So for this equation in the balanced form, we must have 10 according to this information. you must have 10 Fe2 plus ion. So if you want to balance this equation, how do we write down the final answer that you see? The final answer for this one would be, last step you must see this. 10 Fe2 plus, so I will multiply here by 10, so the 10 Fe2 plus will have. Okay, 2 MnO4 minus, so for 2 MnO4 minus, we should have 2 here, multiply by 2. We have 16 H plus. For 16 H plus, we need here 8, because 8 into 2, it becomes 16 hydrogen here. Fe2 as a 4 whole plus. We have 10 Fe3 plus, 2 already we have, so we multiply by 5, 5 into 2, 10 Fe3 plus. 2 Mn plus 2, so 2 multiplied by here. 8 H2O, 8 will multiply by here. If you have done everything correct, okay, you can count the atoms on both sides of the reaction. It should be balanced. If it is not, it means you have done something wrong in this question. Okay, I want you to cross check iron on both sides, manganese on both sides, oxygen both sides, potassium both sides, sulfur both sides, everything you can check. It should be same. Just cross check once, all of you. Tell me, any doubt in this? Is it correct? Did you check? Tell me, is it correct? Can you hear me? Any doubt in this? Yeah, I'll give you some example. I'll give you some question for practice. Definitely I'll do. But is it clear? Any doubt in this? No. The first step is very crucial here. See, the biggest, the problem with this kind of question is what? That this step is crucial. If you have done some mistake over here in, dividing the equation into two halves, right? Every other thing will be wrong. And it's not like you will stop the calculation over here. You'll do the entire calculation till the end. Right? And then you will realize, okay, that you have done something wrong. That kills your time in the test, right? That's why it's very important to understand this. You must be thinking that how they frame questions here in this particular thing. Because it is a multiple choice question, you will have options, right? So how they'll ask the question, they cannot ask you that balance this reaction in the exam. Are you getting my point? If you have multiple choice question where we have 4 options given, then how they frame questions from this? What they do actually, they'll give you this kind of thing. They'll give you a balanced equation in this form. Okay, like for example, X FeSO4, Y KMnO4, and Z H2SO4. What is the value of X plus Y by Z in balanced equation of it? Did you get my point? Yes. Okay, this kind of question they frame in the exam. Okay, so definitely you will have all these things when you solve questions. So let us try one question on this. I want you to do this. Okay, I'll just write down the equation here. You balance this equation depending upon the medium. We have FeCl2 plus K2Cr2O7 plus HCl. This converts into FeCl3 plus CrCl3 plus KCl plus H2O. Balance this equation. Done. Tell me if you are done or any help you require. Okay, take your time. Okay, done. Or done. So tell me the value of x, y, z, p, q, r, and s. Okay. Okay, fine. I'll do this. So first of all, what we need to do? We need to divide the equation into two halves, and that is oxidation half and reduction half. Oxidation and reduction. And to identify this, we need to first find out the oxidation state. So iron is +2 here, and here it is +3. Let me know if you have any difficulty in finding out the oxidation state of this. Chromium is +6 here, and this is +3. All other atoms have the same oxidation state. Okay, so the first half, the oxidation half of this reaction is Fe2 plus converts into Fe3 plus. And the second half is Cr2O7 2 minus converts into Cr3 plus. Okay, this is the two half of the reaction. Okay, now the second point, balance all atom other than oxygen and hydrogen. Medium is acidic. Okay, all atom other than oxygen and hydrogen. So Fe is balanced already. Chromium is 2. Here it is 1, so 2 Cr3. Okay. Now medium is acidic, so we'll balance oxygen by adding H2O on the other side, right? Here we do not have oxygen, here we have oxygen. So we'll add here 7 H2O in order to balance the oxygen atom both sides. But you have added H2O here, so 14 hydrogen also you have added. To balance the hydrogen, we'll have 14 H plus this side. Any doubt? No? Next is what? Next, we have to balance the charge. So 2 positive charge, 3 positive charge. So for that, I have to add 1 electron on this side, so that 3 minus 1 becomes 2. Here the total electron, if you see, 14 positive, 2 negative, we have 12 positive charge we have here. And here we have 6 positive charge, plus 6. This we need to reduce, so it is 6 electron we have to add this side, so that the charge becomes equal. Now we'll multiply this equation. Okay, so we'll multiply this by 6, this by 1, and we'll add 2. Okay, so the final reaction is this. We have 6 Fe2 plus electrons gets cancelled. Cr2O7 2 minus plus 14H plus 6 Fe3 plus 2 Cr3 plus 7 H2. Okay. Then the value of X, if you compare, I'll write down the equation first, the final equation I'll write down. The final equation is 6FeCl2 plus K2Cr2O7 plus 14HCl, because we have 14H plus, converts into, yeah, that's what it happened in this kind of question. Or one silly mistake, everything is wrong. Okay, then we have 6FeCl3 plus 2CrCl3 plus KCl plus we have 7H2. Now in this one, you see the potassium is not balanced here. Yeah. Yes, I'm coming to this point. Potassium is not getting balanced. So this kind of situation you will have in this kind of question. So when you've done all this, just you cross check whether all the atoms are balanced or not. And when you get this kind of situation like here, the potassium is not balanced, then you balance this by hit and trial. Okay, like we have K2 here, which is 2 potassium, just multiply this by 2. If you have done everything correct, then the entire reaction is balanced. You see, you multiply it by 2. Chlorine, if you count this side, 6 into 3, 18, plus 6, 24, plus 2, 26 chlorine atoms this side. 12 plus 14, 26. So this you can do by hit and trial in the last, by guessing. Tell me, did you get it? Tell me guys, any doubt? No? Okay. So this is how we balance the equation. We'll do the basic medium also. But I tell you one thing here. Basic medium, I have given you the rules, correct? Acidic and basic medium. Both rules I have given you. But I want you to not use the rules of basic medium. You just memorize the rules for acidic medium only. Suppose this equation is given in basic medium, right? Then also I'm telling you to use the concept of or the rules of acidic medium. Don't use the rules of basic medium. And you will come till this point, till this equation where we have 14H plus. Now the entire equation here, you can convert into basic medium by doing one change into this, right? And that change is the number of H plus that you are getting here, equal number of OH minus, you add both sides, reactant side, product side, both side you add equal number of OH minus ion. Did you get this? What I'm telling you, now it is fine since we are doing this, so you can go back and see the rules and you can use it. But when you get this question in the exam or in the test, you will get confused that like this was there in acidic medium or this was there in basic medium. You'll get confused over there. So to avoid this confusion, what I'm telling you that you just memorize the rules for acidic medium, the 2 questions we have done on this. Okay? If you get the questions on basic medium, use the same rule. You'll get some number of H plus in that equation. Add equal number of OH minus ion on the both side and write down the net equation. The entire equation converts into basic medium. Did you get it? We'll do some example on this. Did you get this, whatever I said? Yeah. All right, just a second. Did you get it, what I said? Yes. Okay. So we'll do the examples of basic medium after the break. Okay. So we'll resume the session at 6:45. Okay. Take a break now. 6:45 will resume. Take a break. Thank you guys. Hello guys. Yeah. Audible? So yeah. So we were talking about the the balancing of redox medium also how to do it. Just you have to follow the uh, rules for acidic medium only, and in the last the number of H plus you get equal number of OH minus you have to add and write down the net reaction. You will get the answer. Okay, one more we'll discuss in acidic medium, and then we'll see the basic medium questions one. Okay, try this one. And this is the ionic form given: MnO4 minus plus C2O4 2 minus plus H plus. Now, what do you mean by H plus here? Mn plus 2 plus CO2, yes, plus H2. H plus means acidic medium, plus H2. Try this one. Done. Okay. Okay. What is the answer? Okay. So first of all, if you see the oxidation state of manganese here, it is +7 and +7 to +2, so it is reduction, and this one is oxidation. So if I write down the two halves here, that is oxidation and reduction. You see, we have MnO4 minus. This converts into Mn+2. Sorry, this one is reduction. Oxidation state decreases means reduction is taking place. Okay. Electron gets consumed. C2O4 2 minus into CO2. Okay. Next is what? We'll balance oxygen on the basis of the medium. Medium is acidic. Manganese is balanced. Carbon is not balanced. Okay. Atoms other than oxygen and hydrogen. So manganese is balanced. Carbon is not balanced. 2 we have to multiply. Then we balance oxygen and hydrogen depending upon the medium. You have 4 oxygen this side. To balance this 4 oxygen, we'll add 4 H2O, 4 H2O this side. Everything is balanced. 4 oxygen this side, 2 oxygen this side, 2 into 2, 4 oxygen this side. So oxygen is already balanced. So nothing you have to do into this one. Okay. Now, we'll balance the charge. So charge is, you see here, 8 plus and 1 minus, so +7 charge. And here we have +2 because H2 is neutral, +2. So +7 to +2, 5 electrons we have to add. And here it is -2 to 0. So 2 electrons you have to add in order to balance the charge both sides. Okay. Reduction, you see, always consumption of electron. Electron is added on the reactant side. Oxidation, electron releases on the product side. Now we add the two in so that the free electrons gets cancelled. So for that I'll multiply this by 2 and we'll multiply this by 5. Anything you consider, it is the average one we are taking, so it is oxidation number we are taking here. The average value we are taking here. Okay, you don't have to bother about oxidation number or oxidation state unless they ask what is the oxidation state of each sulfur atom or anything like that. Each sulfur atom which is there. Right, you don't have to bother about that. Now when you add 2 here, multiply 2, so it will get 2 MnO4 minus plus 5 C2O4 minus plus 16 H plus gives 2 Mn plus 2 plus 10 CO2 plus 8 H2O. Is this the balanced reaction? If you have any confusion or after finishing it, you just count the atoms both sides. If it is coming out to be same, equal, it means it is correct. Charge also you can count. You see, we have 16 positive charge, 5 negative, 2 negative, 5 plus 2, 7, 7 minus 16. Or C2 for 2 minus, that's what I was thinking. 2 minus, no. So 5 into 2, 10, 10 plus 2, 12, 12 negative, and 16 positive. So net here, we have 4 positive charge and 4 positive charge we have. All atoms are also balanced. So this is the balanced equation. It is given in ionic form here. No doubt? What went wrong? Wrong, Shitesh? Yes? Check your answer. Okay. One reaction of basic medium we'll discuss. Consider this one. MnO4 minus plus SO3 2 minus plus H2O converts into MnO2 plus OH minus. This is the reaction we have, plus SO4 2 minus also. Sulfate ion. I'll do this, okay, you just see. How to do this with acidic medium rule only I'll do it, okay. If your homework is, you have to basic medium rules that we have written already, okay. But I suggest always remember the rules for acidic medium. You can use these rules for both the medium reactions, whether it is acidic or basic. How to use acidic medium rules for this question, I'll explain. So, if you calculate the oxidation state, manganese is again +7 here, right? And SO3 to SO4, this is the oxygen content is increasing, so obviously it is oxidation. And -2, here it is +4, so it is reduction. Okay. So the two halves, the oxidation half and the reduction half. The oxidation half is SO3 2 minus converts into SO4 2 minus. No, OH minus is given here, you see. OH minus is a base. If it is not given, then it will be mentioned. Consider acidic medium, basic medium, like that. Okay? OH minus is basic here. SO4 2 minus. Reduction is what? MnO4 minus converts into MnO2. Okay. Right. So, all atoms, see the reaction of basic medium, I am using the concept of acidic. All atoms are balanced, will balance oxygen by adding water molecule. So we have 3 oxygen here, 4 oxygen here. So 1 water molecule I'll add this side to balance oxygen. And then hydrogen will balance. So H plus this side, 2H plus. 4 and 2, so we have 2H2O this side and 4H plus this side. So all the atoms are balanced now, now charge. So 2 negative charge and 2 negative and 2 positive. So obviously we have to add 2 electrons here. So that net will be 2 negative this and neutral. So here it is 3 negative you have to add. Okay. Now, this one will multiply by 3 and this one will multiply by 2 and we add the 2. So, we get 3 into this, so we have, first of all, write down 2 MnO4 minus plus 3 SO3 2 minus plus 8 H plus gives 2 MnO2 plus 3 SO4 2 minus plus 4 H2O 6 H plus. This is what we get. Okay, now we'll write down the net reaction here. Net reaction is 2 MnO4 minus plus 3 SO3 2 minus 8H plus minus 6H plus. So 2H plus this side, 2 MnO2 plus 3 SO4 2 minus plus 4 H2. Till here, I have used the rules of acidic medium. We haven't done anything for basic medium. Yes or no, guys? We have done only for acidic medium. Okay. Now we want to convert this into basic medium. So for that, H2 I have missed. I'll write down. Okay. I missed H2 here. I'll write down this is here. So this H2O we have here. Just a second. This H2O. Okay, fine. We H2 this side and H2 this side. So 3H2O plus, and when you write down the net reaction, here we have only H2O. Is it right? Please check. Any mistake? I don't think so now. Right? Now, you want to convert this into basic medium. So the number of H plus that you are getting, equal number of OH minus you add, and you cannot add on only one side. In that case, the reaction will be unbalanced. So this side also as well as this side, 2 OH minus. Okay, so this you see here, 2H plus and 2 OH minus. Now, what I said that you have to write down the net reaction, balanced reaction means the net reaction. This forms 2 molecules of water and 1 molecule of water we already have. This one and this one gets cancelled. We get 1 molecule of H2O here. So the net reaction is 2 MnO4 minus. I'll write down here just a second. The net reaction for this is 2 MnO4 minus plus 3 SO3 2 minus plus H2O gives 2 MnO2 plus 3 SO4 minus 2 plus 2 OH minus. This is the net reaction. If you want, you can cross check all atoms and charge are balanced with this. You want to do one on this? You want to do one question on this? Understood? So there's no need to memorize the basic medium rules. It's not tough. Why I'm asking you to avoid this? Because here it is fine, but in the test or in the exam, you will get confused that here we have to add H2O or OH minus, like this happens with most of the students. That's why I'm telling you, just avoid that rules. With this, the answer. Okay, all of you copied? Yes? Okay. Try this question, basic medium I'm giving you. And I want you to correct this. Okay, you can take time, but give me the right answer. H2O, if you need some help, ask me, I'll just suggest you what you need to do. Just a second. Sulfur converts into SO2 plus Cr2O3 plus this. Try this one. Just a second, guys. Done. Oxidation. Why? Oro, are you done? Pradyun? Reduction is this? No, you see. Tell me the oxidation state of chromium. Oxidation state of chromium, it is +6. And here it is plus 3. This is reduction. Plus 6 to plus 3. Whenever oxidation state decreases, it is reduction. Sulfur, yeah, that's what I said in the beginning. That if you make mistake, you will make mistake here only. After that, it is easy. How? You see, that's what I'm telling you. Only one thing you have to keep in mind. Whenever oxidation state decreases, it is reduction, always. Because charge is reducing from plus 6 to plus 3, it means it is accepting electron, no? Then only 6 minus 1, 2 or 3, it becomes 3. Consumption of electron is always reduction. So only one thing you have to keep in mind. Oxidation state decreases means reduction, increases means oxidation. Clear? Okay. So here what happens, you see, minus 2 into 2. So here it is plus 4. Clearly you see. Oxidation and reduction. So the two reactions I'll write down. Just a second. I'll do that in the last Ansh. Let me just finish with this question. Okay, I'll draw the structure of K2CR2. Okay, easy one. I'll draw that. So the oxidation and reduction. Oxidation is conversion of sulfur into SO2, and reduction is Cr2O7 minus 2 into Cr2O3. Okay. Medium is basic, let it be, whatever medium is, we'll consider as it. Okay. So Cr2 and sulfur is balanced. To balance oxygen, we'll add 2H2 on this side. So 2H plus, sorry, 4H plus this side. 4H plus this side. Okay. 7 and 3. So we have 4H2 on this side and 8H plus this side. Okay. Charge, if you balance, here we have neutral 0 charge plus 4 charge, correct? So you have to minimize to 0, so 4 electron. Here we have 8 positive minus 2, net is 6 positive, and here it is 0. So we have to add 6 electron this side. Okay. Now what we do? That the electrons gets cancelled. So this one multiplied by 3 and this one multiplied by 2. Okay. So 3s plus 2Cr2O7 2 minus plus 6H2O plus 16H plus gives 3SO2 plus 2Cr2O3 plus 8H2O plus 12H plus. Okay, I'll write down here the net reaction directly. 12H plus 16H plus get cancelled. We'll get here 4H plus. 6H2O, 8H2O will get here 2H2O. Right? So we are getting 4H plus. So what we need to add? We need to add 4OH minus this side. And this side 4OH minus. 4OH minus and 4H plus gives you 4H2O. 4H2O minus 2H2O gives you 2. So the reaction is, the net reaction is 3S plus 2Cr2O7 2 minus plus 2H2O converts into 3SO2 plus 2Cr2O3 plus I have written here 4 OH minus should be, na? 4 OH minus. 4OH minus. This is the balanced reaction we have. Got it? Tell me, any doubt in this? Okay, so first step you must take care of when you are splitting the reaction into two halves. Okay, that is very important. Okay, now very few things are left. We'll finish this. Okay, write down next oxidizing agent definition. Oxidizing agent, we also call it as oxidant. Oxidizing agent or oxidant are the same thing. These are the compounds which oxidizes others and get reduced. Oxidizes others and get itself reduced. Okay, agent, right? So it is oxidizing agent, so it is oxidizing others. Okay, like for example, a simple one, Zn plus half O2 gives ZnO, right? So here it is -2 oxygen is 0. So oxygen is getting reduced, but when oxygen is getting reduced, it is oxidizing zinc because zinc is 0 here and +2 here, right? So zinc is getting oxidized, right? Oxygen is getting reduced. So the one which is getting reduced is the oxidizing agent. Is the oxidizing agent. Did you get my point? A substance which goes under reduction, like it oxidizes other, compounds, and hence it goes under. It is called oxidizing agent. I forgot to draw the structure of K2Cr2O7. Ansh, I'm doing it here. See, K2Cr2O7. The structure is this. And to neutralize, we'll add K plus here. This is K2Cr2O7. You see the structure here? +2, +2, +1, +1, +6. Clear, Ansh? Okay. So oxidizing agent is this. Just reverse of this is reducing agent or reductant. Write down. Reducing agent or reductant. These are the compounds. These are the compounds which reduces others and get itself oxidized. These are the compounds which reduces others and get itself oxidized. Okay, like in this one, zinc is the reducing agent or reductant. Zinc is the reducing agent or reductant. Done? Okay. Write down heading, some important oxidizing agent. Some important oxidizing agent. This is important. And the application of this we'll see when we have, when we discuss about the concepts of equivalent, right? With the help of change in oxidation state, we can find out the concept, we can find out the number of equivalents, which is used in the calculation of normality, the concentration term. Remember, I have discussed this concentration of molality and molality in the mole concept one, but I did not do normality, and I told you that normality we'll discuss after redox reaction, because the concepts of equivalents, or if you want to find out the number of equivalents, that we can find out with the change in oxidation state also. So till now we have discussed about oxidation state. We understood how to find out the oxidation state. Hence, we can find out the change also, and then we can use this particular concept to calculate the number of equivalents. Okay. So few things that that JE or any competitive exams, they understand that this particular information you have. Okay, and that is one of the thing in this is the change of oxidation state for various oxidizing agent. Okay, so heading some important oxidizing agent. Oxidizing agent. This thing you have to memorize. Important, you cannot miss this. Okay. The first thing is KMNO4. KMNO4. KMNO4, you see, manganese here is in +7 oxidation state, and the change of manganese in +2 is possible, right? +4 is also possible, and +6 is also possible. +2, this change happens in acidic medium, and this you should know, very important. Okay, this is neutral medium, and this is basic medium. So what is the change in oxidation state in acidic medium? It is 5. Okay, this information we require. So this you have to memorize. Second one is K2Cr2O7. Write down quickly, I'll finish this. Okay. K2Cr2O7, you see, Cr+6 converts into Cr+3, medium is acidic. Cr2O7 minus 2, this way also you can write, converts into Cr2O4 minus 2 in basic medium. You can find out the oxidation state also. Okay. Third one is H2O2. H2O2 is a hydrogen peroxide -1 oxidation state, and it converts into H2O, that is -2, in all medium. In all medium. Done. Another one, MnO2. MnO2, we have acidic medium reaction only. It converts into +4, converts into Mn+2 in acidic. I'm giving you the important one, which generally they ask in the
So
exam.
can you go back 1 second? Just one.
1 second, just 1 second, I'm going back. So we have F2 converting into 2F minus in all medium.
Done. Thank you, sir.
Yep. Write on one note. Fluorine is the most powerful oxidizing agent. Fluorine is the most powerful oxidizing agent. Second point. Lithium is the most powerful reducing agent. Alkali metals are good reducing agent. Alkali, alkaline. Okay. S block elements are good reducing agent. They have high tendency to accept electron. Okay, electropositive character. Okay. So alkali metals are good reducing agent. Same for alkaline earth metal. Lithium is the most powerful reducing. Okay. Now the last thing here, that is disproportionation reaction. Disproportionation reaction. Write down, in this reaction, in this reaction, the same element goes under, in this reaction, the same element goes under oxidation and reduction reaction. Write down like this, goes under oxidation and reduction. Reaction you don't write. The same element goes under oxidation and reduction. Okay. So when the same element goes under oxidation and reduction, reaction is known as disproportionation reaction. For example, H2O2 converts into H2O liquid and O2 gas. This is aqueous. So if you find out for oxygen here, you see H2O2 is a peroxide. It is hydrogen peroxide, the name of the compound is, and you see it has a peroxy linkage. This is a peroxy linkage. So since it is a peroxide, oxidation state is -1. In oxygen it is -2, and here it is 0. You see from here to here, oxidation state increases, so it is oxidation. Okay, and from this to this, oxidation state decreases -1 to -2, it is reduction. The same element is going under oxidation and reduction, hence the reaction is disproportionation reaction. Important one, they ask this question like which of this reaction is disproportionation, like this. They'll give you 4 reactions to identify. Copied? Tell me. Done? Okay. Most examples of this reaction are decomposition. Can say that decomposition. The same element will have 3 different oxidation states. Okay, -1, -2, 0. Decomposition can say that. Okay, right. Now your homework is this. Okay, homework is to balance this reaction. This reaction is a disproportionation reaction. P4 plus OH minus aqueous medium, so H2O is also there, and it converts into PH3 plus H2PO2 minus. H2PO2 minus. Balance this reaction. It is disproportionation reaction. Medium is basic. Phosphorus, you see, one is getting oxidized, other one is getting reduced. So I want you to try this and share your attempt on the group. Okay? Yeah. Okay, so this is it for the session today. Next class will continue with this mole concept 2 we'll discuss. Okay, concepts of equivalent normality and other things. Okay, thank you guys. Take care. Bye bye.